Alright, you shouldn't be watching this video until after you've had a chance to try your practice quiz, so pause me if you haven't tried yet. I am going to go through how I would have done this problem. The first thing that I see is that the bases have to be the pentagons, because the pentagons are your two congruent shapes. You'd have a pentagon on the front and a pentagon on the back, if you can picture that one back there. Right? And so this is one of those cases where our prism is kind of knocked down so that its bases are not on the floor and on the top anymore. It's knocked down. So the shape of the bases, regular pentagons actually, because it's 8, 8, 8, 8, 8, all the sides are congruent. That means that when I work with my area of my base shape and the perimeter of the base shape, I should be thinking about the pentagon. So it might actually help you to draw a pentagon out just so you can focus on the base shape for a while. They gave me all the sides were 8. They gave me the apothem was 5.5. And so when I go to find B, which is the area of my base shape, I'm going to use the 1/2 AP formula. The apothem is 5.5, and the perimeter of this base shape would be 8 plus 8 plus 8 plus 8 plus 8, which is 40. And actually we're going to use that again when we do the perimeter of the base shape. 8 plus 8 plus 8, 5 times, equals 40. So again, when you're working with the capital B and the capital P, you're thinking about that pentagon. So let's get those typed in. 0.5 times 5.5 times 40. So the area of my base shape is 110 square units. The perimeter, 40 units. And then height, don't get messed up on height, and it's not talking about the height of our pentagon at all. It's talking about the height of the prism. And remember, if something's laying down, that doesn't mean that it got shorter, it just needs to be measured differently. So we're going to measure from the foot to the head, or from base to base. Probably makes more sense. So from this base back to this base, our height was 10. Once you get that, then the formulas are just plugging those numbers in. So surface area, there are two bases. So 2 of those 110s, plus that big wraparound rectangle would be the 40 times the 10. I got 620. Since that's an area, it's still in square units. Volume is the area of the base shape times the height, that being the height of the prism. So add another 0 to that, you get 1100. And that would be if we were trying to fill up this prism with cubes. Cubes of water or cubes of whatever. So it would take 1100 cubes to fill up that prism. Now you want to make sure that you have these 3 things ready to go. You'll need the gold sheet for this week, your prisms worksheet from yesterday, and your formula sheet that we started to fill out yesterday. We're going to call this week 19, and we'll just say that you did the prisms worksheet. Give yourself a completion score out of 10. It was 4 pages long. It was a little rough, a little long, and thank you for doing your best. If you tried every single problem on all 4 pages, please give yourself a 10. Don't be shy to give yourself something lower. If you practiced at all, that's better than doing nothing. So be honest when you give yourself a completion score. Let's just quickly go through the assignment and see how you did. Yesterday we kind of talked about these top 4 problems, so hopefully you had a chance to figure those out. If not, save your questions for me. But if we go down to number 5, a star is a decagon because it has 10 sides. And there's a star on the top, star on the bottom, so that's a decagonal prism. In order to find the area of that star, I don't know how we would have done it. We had to split it up, but luckily they gave us square inches for one post-it note. So that was the area of our base shape. The actual prism was 1.5 inches high. And then if each side of the star was 1 inch long, we would do 1 plus 1 plus 1 plus 1. We get 10. Plugging all those into our surface area formula, you should have gotten 25.5 square inches. Number 6 was a triangular prism because it has a triangle on the front, and if you can imagine, a triangle on the back. The rest of the sides are rectangles. So I'm thinking about this triangle when I'm doing anything. So when I'm finding the area of the triangle, I'm doing 1/2 base times height. And it told me that the bottom part of the triangle is 20 and that it was 8 feet tall. That's how I got 80 for the area of the triangle. The height was 25, and remember that would just be the distance between triangle to triangle. So when they told us that the roof was 25 feet front to back, that was actually the height. Perimeter of the triangle would be this bottom 20, and they told me these were 6.5 and 6.5. So your perimeter is 33. Getting the 80 and the 33 and the 25 plugged into the formula should give you 985 square feet. I wish I would have had time to help you out with this one yesterday because it required a lot more work to find the area of the base shape. The base shape is the pentagon, and we know all the pentagon sides are 921. What you probably didn't realize is, well, you needed the apothem. Maybe you knew that you were supposed to half that 921, and that would give us 460.5, but maybe you didn't realize what that angle would be. And so here was my thought process. If I split that into triangles, I know I'm going to get 5 congruent triangles, but technically we're putting the heights in there for each of those too. So if you take this total center circle and you divide it into the 10 equal pieces, you're going to get 36 degrees for each of those. So that's why I knew that this was a 36-degree angle. I did a little trig on that, and that's how I figured out my apothem. That was the tough part. That's what I wish I would have had time to show you. That did affect us because we needed to use that 633.8 as our apothem when we found the area of the base shape. The perimeter is just where you add up the 5 921s on that pentagon. They told us the height of the pentagon, the building, the pentagon. Now, there was one thing where they don't need a tarp to cover the bottom of the pentagon. So can you see why I crossed out the 2? Because I don't want 2 bases to be covered. I only need the top base to be covered. So just one base and then all those lateral faces is just fine. So I didn't need the 2 in the formula. After that, it's just plugging things in. On this one, what did we have to do? Well, the great part is that they didn't care about either of the bases. So I didn't even have to worry about finding the area of the triangle. Only the windows on the sides is what we cared about. So I just got rid of those 2 bases right away. The perimeter was easy enough to figure out, as long as you knew the base was the triangle, the equilateral triangle. So 3 160s added together makes 480. They told me that the height of the building was 200. And if I don't need the 2B, then I can just do the PH part and get my lateral face area. That's my lateral surface area, they call that. I'm hoping after a few tough problems, these were a little bit easier. I saw the base of this as just being the bottom and the top. Honestly, when it's a box like this and everything's squares or rectangles, you could have chosen a different side to be the base, but I just chose the top and the bottom. So I was working with that rectangle again. Again, the rectangle that's on the top and the bottom is a 4 by 1.5 rectangle. So its area is 6. If I add all 4 sides together, well, you know what? I don't need a perimeter because I'm just finding volume. So it looks like I skipped that. But if I do 4 times 1.5, I get an area of the base shape being 6. The height of this prism, the distance between the 2 things that I chose as bases, was 5. And so 6 times 5 is 30. Remember that volume is measured in cubic inches, so 30 cubic inches. Number 10, again, probably the trickiest part is knowing that it's those triangles that are your base shapes. So when you're calculating B, you're finding the area of the triangles. 1/2 base times height, 1/2, 2 times 5. So the area of our base shape is 5 square meters. And the height is the distance between the triangles on the front and the back. The distance between those base shapes, which is the 4. Again, this is a laying down one, so 4. 5 times 4, 20 cubic meters. Number 11 was kind of nice because they gave you the area of the triangle. That was that 9 square inches. Cake was 3 inches tall. Probably the simplest problem on the worksheet. They gave us B, they gave us H. Number 12 took a little bit more work. They gave us the volume. If you're talking a base of 12 by 12, that would have an area of 144. We're supposed to find the height, so it's just a simple algebra problem. We're going to divide by 144. The height of each tier on this cake is 4 inches. So in the next, number 13, I had a 12 by 12, a 10 by 10, an 8 by 8, and a 6 by 6 cake, all stacked on top of each other. So the 12 by 12 I already knew the volume. 10 by 10 has a base area of 100 times the height. 8 by 8, a base area of 64 times the height. Base area of 36 times the height. Add all 4 tiers together and you have so much cake, 1,376 square inches. I chose these as my prisms because this one looked like it had a triangle top and a triangle bottom and rectangles around the side. This one's a nice standard box. This one looks like it has an octagon on the top, probably an octagon on the bottom, and these would be rectangles on the sides. Any building that just goes straight up and has a flat top, a flat bottom that are the same sides, that should be okay. I didn't choose this one because to me it looked like it came to a peak, more like a pyramid. This one, technically not a prism because it has a rounded bottom and top, so they're not polygons. It has a lot of similarities though, but it's not technically a prism. On this one, number 15, I went back to that other pentagon problem because I had already figured out the area of the base shape. And the area, the height was 77. So automatically I knew the volume pretty much of the whole kind of compound here. But that actually includes the courtyard, and it says do not include the courtyard. So then I went back and I found the volume of the courtyard. Now this problem was nice because it gave me the area of the courtyard. So I took area of the base shape times the height. Here's the volume of the courtyard. So if you take the whole compound minus the courtyard, that'll give you the volume of just like the building pentagon. There's like trees and junk in the middle. So, and then here's just a little application. If you know the volume of a building, you can multiply it by the cost to heat each cubic foot, and that tells us how much it costs to heat the pentagon for a year. The very last one, just making sure you had the concept. If you know the area of the base shape, which we could count the squares on that, I counted 14 square meters for the base shape. They told me that the height was 3.5 meters tall, so easy to compute the volume. Just area of the base shape times the height, 49 cubic meters. So that just means there would be 3.5 layers of those 14 blocks.